Here we are again, back to another lesson of Algebra 2 Notes with Miss Faust. This one, I know you're super excited because you're like, oh, graphing quadratics, I totally remember that from Algebra 1. So you're going to be like super good at this, and that's awesome. That's just what I'm hoping. But just in case you need a little help, here I am to help you review. So our essential question is, how can you graph a quadratic equation in standard or vertex form? And to start the notes, I just gave you the basic graph here of a quadratic function, y equals x squared, and that way we can compare our other graphs to this basic one as we do more work with them. So when we have this first equation, what we'd want to think about is building a table for it. And the reason we're going to do that is because we're also going to use a table when we do the other graphs. So my table is going to go from -2 to 2. One thing to remember about quadratics is that when you square a negative number, you get a positive number. So -2 squared, if you use a calculator for that, make sure you're putting parentheses around the -2. The calculator's otherwise always going to give you the wrong answer. So -2 times -2 is +4. -1 times -1, that's what the squared means, is 1. 0 times 0 is 0. 1 squared is 1, and 2 squared is 4. So you can see I've already put those points here, -2 and 4, -1 and 1, 0 and 0, 1 and 1, and 2 and 4. The domain for this function is all real numbers, or -infinity to infinity, however you prefer to write that. The range, however, is not all real numbers, because if you take a look at this graph, there's no values. Range is down here, domain is here. There's no values of this particular one that are ever below the x-axis. Occasionally there will be, depending on the function we're graphing, but this parent function, the range is just 0 to infinity. Or if you want to write that in interval notation, yeah, inequality. I wrote inequality. Interval notation would be 0 to infinity with a square bracket at the 0 and parentheses at the infinity. The vertex then, so the vertex, when we're talking about a parabola, the vertex is always this center point. The vertex is always going to go in the middle of your table. And the reason that the vertex is super helpful and super important in a parabola is because on both sides of that, it's symmetric. So from this vertex, you can see those points are symmetric on either side of it. Those points are symmetric on either side. And that symmetry is what we're going to use in the y values to help us build our tables really quickly. So this graph has a vertex at 0, 0. Other graphs will have vertices at different points, but that's what we're going to look at next, is how to find those. So we have two types of quadratics. We have quadratics in vertex form, and when a quadratic is in vertex form, it's written like that. And vertex form is a nice one to start with because vertex form relates directly back to what we did with transformations in the last unit. So the H is your shift right or left, your K is your shift up or down, and your A is a vertical stretch. So what's going to happen is this original shape I had, if we have an H, it's going to move left or right, and that vertex point is the point that moves. If we have a K, it's going to go up or down, and then the A is going to tell us where these other points go. They're going to be stretched up more in some cases. So let's just see. We're going to do 3 examples of this. We're going to do y equals x minus 3 squared plus 1. We're going to do, actually, I'll start with just that one. If I have room, I might put a second one on the same graph. But let's just start with that and see where we end up. So when we have vertex form, what we want to start by doing is we want to start by finding the vertex. And the vertex always comes from this H and K. Once we have the vertex, we're going to make a table of values, just like this table of values. So the vertex tells us where the middle point goes, and then we build up and down from there. And finally, we plot the points. So if we look at our first example here, we've got this -3 and +1. Notice we have no A in this one. That means that the graph's not going to be stretched out any. So our vertex in this is at 3 and 1. And remember, -3 means that it goes to the right 3, so that's why that's a +3, even though that was a negative up there. So we're literally just using the value of h, so h is 3, 3 and 1. So what we need then is we need to make a little table so that we can plot the rest of this. So I'm going to always use 5 numbers in my table. You can only see 4 of them, but I can fix that. Have no fear. Technology is here. Sorry, too much coffee today maybe? There we go. 1, 2, no, you still can't see them all. Silly. 1, 2, 3, 4, 5. Okay, now we have room for all of them. So we put our vertex right in the middle, 3 and 1. And then what you want to do is you want to just count up and down from your vertex to get your other x values. So 3, 2, 1, and 3, 4, 5. Now we literally just plug in our x's to find our y's. You may remember before we talked a little bit about the symmetry in the table. So the good news is you only really need to plug in 2 values because the 2 up here are the same as the 2 down here. So I look at this 3 and 1. I'll plug in 2 first. I'll do 2 minus 3, and you can grab a calculator if you don't trust my algebra here, my arithmetic really. 2 minus 3 is -1. -1 squared is +1, and +1 plus 1 is 2. Next I'm going to plug in 1. 1 minus 3 is -2. -2 squared is +4, and +4 plus 1 is 5. So I'm just plugging in these x's into my equation to figure out my y values. And then I know that on the other side of the vertex, it's going to be symmetric. So if it goes 1, 2, 5 that way, it goes 1, 2, 5 going down as well. So my first point is 1 and 1, 2, 3, 4. Yeah, 1 and 1, 2, 3, 4, 5. Then I have 2 and 2. Then I have 3 and 1. Then I have 4 and 2. Then I have 5 and 5. And I can connect my points with a nice curve, and I've got a beautiful graph of my quadratic. Domain of this one would still be -infinity to infinity. Range of this one would be a little bit different because this one starts here at 1 instead of starting at 0. So the range of this one would be 1 to infinity. Okay, so let's go on and look at a second example. I am going to turn the page because I don't have room. If you have room, you're welcome to just write the next example down and then graph it on the same grid. You don't need to start a new grid for each one of these, as long as when you're done you can tell which one's which. So questions, notes, example 2, and you know what? Let's just make this the last one we do, perhaps? Yeah, this is enough with vertex form, and then you'll be able to use this, these ideas. I think this will be plenty for you guys to see. X minus 3 squared minus 5. So again, I'm going to need a graph over here. I need to find my vertex. The vertex, remember, comes from this number and this number. So the vertex for this one would be 3 and -5. If this had been x plus 3, and that's the example that I left out, if this had been x plus 3, then that would be a -3 instead of a positive. So it's always, one way to think about it is it's the opposite. Or if you remember, again, what we said at the beginning of the year, that's the word opposite. Sorry, I wrote it too small. The x's lie. So the x part of the vertex lies when you compare it to this. -3 becomes +3. Now we build a little table. X and Y. We leave space for 5 numbers. I don't know why my Y's are so long, but that's okay. We put our vertex right in the middle. 3 and -5. Why did I use 3 again? Oh well, too late now. Count down, 2, 1, up, 4, 5. I think you guys can count up and down even if this was a different number. Plug in 2 of these. Don't need to plug in all of them. This time I'll just go this direction just for something different because remember they're the same on both sides. So if I plug in 4, and for this one I'll also just show it. I know sometimes it's helpful to see where the numbers are coming from. So 2 times 4 minus 3 is 1 squared minus 5. Square next, then multiply. So 2 times 1 minus 5. 2 minus 5, -3. So I put a -3 there. And then for the 5, I'll do that one down here. 2 times 5 minus 3 squared minus 5. 2 times 5 minus 3 is 2 squared minus 5. Parentheses, then exponents, then multiplication. And I get 3. And again, these numbers go up here as well. So -3 and 3. This one has lots of 3's, but that's okay. So I'm going to start with 1 and 3. 1, 1, 2, 3. Is that right? 3? Yep. 1 and 3. 2 and -3. 3 and -5. 4 and -3, 5 and +3. So when I connect them, this time I get a skinnier parabola. That makes sense because this 2 in the front tells us that it's stretched out vertically. It's shifted 3 to the right. I can see that there, and it's shifted down 5. Again, we could talk about the domain and range of these. The domain is still going to be all real numbers. And the range for this one would start at -5 and go to +infinity. You will have graphs that open down sometimes. I happen to do 2 that open up, but if this was negative, your graph would open down instead of up. Okay, next we're going to go on and we're going to look at equations in standard form. Those were in vertex form. Again, you probably have room on your same page, but I like to try to remember to write large so you can read my handwriting. So standard form is when we have ax squared plus bx plus c. So our equation is in that form, y equals ax squared plus bx plus c. So when we're in standard form, the first thing we have to do is find the vertex. If you're in standard form, you don't have the vertex already in front of you, so that's what we do first. And in order to find the vertex, the x value of the vertex is equal to -b over 2a. So it's a formula you use with these. And then to find the y, you plug in the number that you get for the x. So you're really just building the table again, but you use the function and you plug in the x. And let me show you how that works in a couple examples. I think when you see it in examples, you'll be like, oh yeah, no problem. Y equals x squared plus 2x minus 4. So if we start with that, we want to look at this first and we want to figure out what our a, our b, and our c are. So in this one, our a is 1, that's hidden. Our b is 2, and our c is -4. So I need to find my vertex first. To find my vertex, I do x equals -b over 2a. So in this problem, that's going to be -2 over 2 times 1. -2 over 2 times 1 is -2 over 2, which is just -1. Then to find the y, I go back to my equation, and everywhere there was an x, I write this number. So I'm going to do -1 squared plus 2 times -1 minus 4. Just using this equation, plugging in -1. When I do that, -1 squared is 1. 2 times -1 is -2. 1 minus 2 is -1 minus 4 more is negative 5. So that's the y value of my vertex. So my x kind of got mixed up here. There's my x value, there's my y value. So for this one, my vertex is at negative 1, negative 5. So when I think about my table, that's what's going to go in the middle of my table. So I put my negative 1, negative 5 right there. Then I count up and down. So negative 1, negative 2, negative 3, negative 1, 0, 1. So basically you're thinking of going to the left and then to the right of that number on your x-axis. And you can actually draw it in if it helps you. If I had already drawn my grid over here, it might have been even easier for me, because then I could be like, okay, if I start at negative 1, that's right here, then I go negative 2, negative 3, then I go 0, 1. Okay, so could help. Now we need to fill in the other values. Again, we go back and we use the equation that we had. I forgot to write the other steps up here. Find the vertex, make the table, and plot the points. Same things as before, the only difference is now you actually have to find the vertex. So, okay. So for our table, I'm going to use 0 because I think 0 is going to be an easy one to plug in. So when I want to find the y value for 0, I know y is going to equal 0 squared plus 2 times 0 minus 4. That is easy. 0 and negative 4 give me negative 4. For 1, then, I like the idea of 1 better than a negative number. 1 plus 2 times 1 minus 4, so 1 plus 2 minus 4. I think that's 0. That is 0. Okay. And then the same numbers go in up above, so I fill those in, and then I make my graph. Negative 3, 0, negative 2, negative 4, negative 1, negative 5, 0, negative 4, 1, 0. And I have a beautiful graph of that quadratic function. Okay, again, if I'd had a negative out front here, then my graph would have opened down instead of up. But the important step in these is finding the vertex. I'm actually going to show you another example of finding the vertex, but I'm not going to go through the whole graph procedure again, because I think once you find the vertex, you'll know how to do the rest. So, oops, this one was example 1, or example 3 if you like to count consecutively in each set of notes. So example 2, let's just find the vertex this time. If we have y equals 2x squared minus 4x plus 3. So in order to find the vertex, again, we think about what a, b, and c are equal to. A is 2, b is negative 4, c is 3. So the x part of the vertex is going to be the opposite of b divided by 2 times a. The opposite of negative 4 is 4. 2 times 2 is also 4. So the x value is 1. The y value then, I'm going to plug in the 1. I'm going to do 2 times 1 squared minus 4 times 1 plus 3. 1 squared is 1. 2 times 1 is 2. 2 minus 4. Well, 4 times 1 is 4. So 2 minus 4 is negative 2 plus 3 is positive 1. So the vertex for this one is 1 and 1. And if I were to show you the whole thing, I'd put 1, 1 here, make the table, but you've seen that enough times. I think it'd be more valuable to do one more example of finding the vertex. So let's say in this one, y equals negative 3x squared plus, let's make that 12x minus 2. Okay, this one's going to be really obnoxious to graph, so we're not going to graph it. We're just going to find the vertex. A is negative 3, B is 12, C is negative 2. So our x value is the opposite of 12 divided by 2 times negative 3. So that's negative 12 over negative 6. Negative over negative is positive. 12 divided by 6 is 2. And for the y, I plug that in. Negative 3 times 2 squared plus 12 times 2 minus 2. And the big warning about this is always respect your order of operations. That's where people make the most mistakes with these. So when I'm evaluating this, 2 squared is 4. Negative 3 times 4 is negative 12. 12 times 2 is 24. So I'm going to do negative 12 plus 24, and then that minus 2. Negative 12 plus 24 is positive 12 minus 2 is 10. So the vertex in this one, I'm almost out of space, but I'm going to do this. The vertex in this one is 2, because that was my x, and 10. Oh, geez, you can't see that. 2 and 10. 2 is the x, 10 is the y. If we wanted to graph it, put it in the table, fill in the table, plot the points, yada, 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 connect them with a smooth curve, end up with a beautiful parabola. Sound good? Good. Go back, look over this. If you have questions, write them in the margins. If you find any mistakes that I made, which is always possible, write them in the margins. That's what this is for. And I will see you soon in class. Thanks. Have a great day, Mustangs. Woo!